Join us on a journey to infinity and beyond, to a place where the rules of physics collapse, where time and space twist and distort, where we can see into the future and travel back to the past, to the most extreme, least understood place in the universe, into the heart of a supermassive black hole. A black hole, terrifying and fascinating. It's the universe's ultimate enigma.
How can you not love a black hole? It's the endpoint of everything. It's distorting space, distorting time. There's some ideas that if you fall into one, you could pop out someplace else in the universe. It's a science fiction writer's dream.
And now consider that these things are real, that we actually observe thousands of them routinely. Black holes are monsters, real monsters in our midst, and they will never cease to be dramatic.
What would we see if we could look this monster in the eye?
I would love to have a trip around a black hole, looking out the window, seeing this scary black disk in front of you and marveling at the gravitational distortions of light, and experience this spectacular manifestation of all the stuff that I've just calculated and never seen.
What would we discover if we could actually venture inside a black hole? Sending a hypothetical probe into the supermassive black hole at the center of the Milky Way, known as SAG-A-star. Our destination is so distant that even traveling at the speed of light, the trip takes 26,000 years. On our journey across the galaxy, we pass tens of thousands of other black holes.
We think that there's sort of a zoo of black hole sizes. There's hypothetical microscopic black holes. There's middleweight black holes that are formed when stars collapse and maybe another star falls onto them. And then there are the supermassive black holes. They're lurking at the centers of galaxies.
Most black holes start life with the death of a giant star.
When the star collapses, it all gets blown out in the most violent fireworks in the universe, a supernova, the explosion of a star, which shines briefly with the brightness of 10 billion stars.
Then, gravity seizes control of the star's core.
A star is already crushing itself down under gravity, but what stops it is the pressure of the light coming out of it. So if a star can no longer produce that light, it's going to crush itself down. And it'll get smaller and smaller and smaller until finally no force can hold it up and it just crushes in on itself.
Gravity pulls every speck of matter inwards, crushing lumps of solid iron the size of Mount Everest, down to the size of grains of sand.
You think about solid matter as being something that's so solid, so strong that it can't compress anymore. Think of iron. But really, iron is mostly space. The space between the protons and neutrons at the core of that iron atom is huge. So at some point, for some stars, the compression is so large that you can end up smashing these core neutrons and protons together.
What happens next is a mystery. Gravity squeezes these subatomic particles together in ways that science simply can't explain.
The inside of a collapsing star is unimaginable. There are temperatures and pressures that we don't really even have very good numbers for. We know for a fact that we will need new physics, things that we have not yet discovered, to explain what goes on inside a black hole.
The massive star crushes down until it's a fraction of its former size. But the star's original gravity remains, creating a gravitational field so strong that nothing can escape. The result is a black hole. Most black holes are roughly 10 to 20 times more massive than our sun. But at the center of galaxies, black holes can be billions of times bigger. These monsters are more than massive. They're supermassive.
The coolest word in astronomy is supermassive black hole. As you can tell by the name, this supermassive black hole is consuming a supermassive amount of material, and we know that there's one in the center of our Milky Way galaxy.
Our hypothetical probe is closing in on the supermassive black hole, SAG A-star.
Supermassive black holes are actually quite omnivorous. They like to eat gas, but you know, if a star comes within reach, they'll gobble that up too, or a planet, or a spaceship, whatever. They're not so fussy.
They even eat each other.
But over billions of years, many stars can die in one area, and the resulting black holes can move together and combine into bigger and bigger black holes.
SAG A-star is an omnivore and a cannibal. It has gorged on anything and everything within its reach for at least 12 billion years.
Our black hole has pretty much eaten up all the food in the neighborhood and settled down to a quiet, middle-aged lifestyle where it's not eating much. So when we look there, you don't see much going on at all, which is actually very fortunate, because we probably couldn't live here if our black hole were binge eating like in its youth.
In 2010, NASA's Fermi Space Telescope discovered what may be evidence of our black hole's binge-eating youth. Two vast bubbles, fizzing with ultra-high energy gamma rays, blasting out from the galaxy's center for 30,000 light years above and below its flat plane. Some scientists believe they're a kind of cosmic burp, belched out as the supermassive black hole gorged on a giant star.
The reason that the black hole can fit within it all these enormous amounts of stuff it's eaten is because it's like the ultimate trash compressor. It just squeezes the matter down to ridiculously small scales. So the weight of a black hole is simply the sum of everything it's eaten since the beginning of our universe.
After billions of years of binge eating, SAG A-star weighs in with 4.6 million times more mass than our sun. But all this mass exists in a region only 20 times as wide as the sun, surrounded by a luminous veil of stars, dust, and gas. Approaching the black hole, something strange is happening to the probe. So far, it's followed a perfectly straight path, but now its trajectory is starting to curve.
From the probe's perspective, nothing weird is really happening. But if you're on the outside looking at this probe, this straight path is not going to be a straight path. It's going to get pulled off the straight path by the actual space around the black hole.
The probe's course hasn't changed, but the space around it has. And as space changes, so does time.
Time flows differently when you get near a black hole. If the black hole is spinning, it drags space around with it. It is just bizarre. They take all of our concepts of common sense and intuition and everything and just chuck them right out the window.
SAG A-star is distorting space and time. So as the probe draws closer, time is warping until the ultimate science fiction fantasy becomes reality. At the black hole, the probe really can travel back to the future. As it nears the supermassive black hole at our galaxy's heart, the probe is at the mercy of one of the most fundamental forces in the universe. A force with the power to twist space and send the probe traveling through time.
Gravity is something incredibly commonplace. We're always dropping things, we're not flying off the surface of the Earth. It's a part of our lives from the moment that we're born. But it turns out it's a very mysterious and deep part of the universe. When something has mass, it has the ability to bend space.